Paper 1R, June 2016, question 12. So this is a practical based question. It's not something you're necessarily supposed to know that much about. It's just testing your knowledge of how to do experiments and how to analyze data. So it describes a student using apparatus to investigate pressure and volume inside a gas syringe. It gives you a set of results. So she's measured the pressure in kilopascals there, and she'd measured the volume of the gas in centimetres cubed, and she's done that twice. So one time is as she was putting weights onto the platform, so loading, and then again as she was taking them off. So she's done repeats, and then she's taken an average. So it says complete the table by filling in the missing value. So it's given you that the average is 92. One of the values was 90. So in order for the average to be 92, the missing reading would need to be 94, so that 92 is exactly halfway in between those two results. Suggest why the student takes readings for increasing the pressure and for decreasing the pressure. Now there's two things that you can talk about here. One, just from a practical point of view, is she has done repeats. And why do we do repeats? Because we're trying to make the experiment more reliable. And that's the word that you want to use, not accurate, more reliable. You could also have so that you could calculate an average. Again, that's kind of the same thing. It does make it more reliable, but you're giving a bit of extra detail. Another reason why we take more than one reading is so that we can spot any anomalies. So those are the standard answers that you should always think of. You could always try and link it to the actual physics of the experiment as well. In this case, something like temperature might have affected the results. So as she was doing the experiment, there might have been a temperature change. So she's trying to do values to spot if that's happening. Any two of those is fine. So they've plotted the graph for you, and they've done 2 lines of best fit, or 1 line and 1 curve. Suggest a reason why the axes do not start from the origin, and it's for 1 mark. So your standard answer there, if it's not started from the origin, is because you are trying to make the graph as big as possible. You are trying to use as much of the grid as you can. So it's just to make the graph more sensitive, more easy to read by increasing your scales. So you could go for uses the whole grid, increases the scales, something like that. Or you can go the scientific route and you can say that it wouldn't be possible for pressure or volume to be 0. So it's never going to go through 0, 0 anyway. So the student's drawn both a straight line of best fit and a curve of best fit. Discuss which line is correct. So when it says discuss, it wants you to mention both possibilities. So it's not saying explain which line is correct. It's not asking you to choose one and state why that is correct. It's asking you to suggest reasons for both. And it's worth 2 marks. So 1 reason for each choice would be fine. Now looking at it, the straight line of best fit is quite good because for the straight line, it has equal numbers of points on each side. So if you're drawing a line of best fit, that's what you're aiming for. So that's a justification for why the straight line of best fit is a good one. But then for the curve line, more of the points, or pretty much all of the points, are on the line, touch the line. Okay. So part 3, suggest a way that the student could make this experiment valid. So when you see the word valid, it means it's making it a fair test, which they've nicely told you as well. So this is about controlling other possible variables that might affect your experiment. The main thing that can affect pressure and volume is temperature. So this is requiring you to know a little bit about air pressure. So you could control the temperature. You could come up with other sensible suggestions. Make sure no air gets in or out of the syringe. In this case, they will let you get away with keep the apparatus exactly the same. I don't normally like that as an answer because it's a bit vague. Try and be more specific. Wait for some time after each reading. Again, that links into the temperature. Just making sure that it doesn't the gas doesn't heat up as you're compressing it. Temperature is the best way to go with that question. And then lastly, suggest 2 ways in which the student could improve the quality of her data. Now, with any kind of graph, what you are aiming for is to have a good spread of points. So for this set of results, what you do notice is there's a big gap in the middle of the graph where you don't really have any data, and we're kind of guessing at what's going on. So one of the suggestions you might want to do is take some readings between 60 and 80 for the volume of the gas, or take some readings for the center values, the middle values. Another suggestion you could make is to extend the range of your readings. So take more values below 50 centimeters cubed or above 100 centimeters cubed. So those are 2 ideas that are directly linked to the data itself. Those are good answers to learn because you can apply that to any situation. And another standard one that you could go with might be to increase the sensitivity of the instruments. So that is to do with the scale. The real trouble with that word then, sensitivity. Okay. So that's linked to the scale. So you're going to use instruments that have a smaller scale, like a millimeter scale, for example, instead of a centimeter scale. Okay, so long question here. Part C, the student concludes her data validates the relationship between pressure and volume. Okay, so she's saying that her data agrees with what she thought about pressure and volume. So use data from this table to evaluate her conclusion. Now, the relationship between pressure and volume should be, and you need to remember this, that pressure times volume is a constant. That's knowledge that you're expected to know. And that's Boyle's law. That's not necessary for the answer, but just good to know. And once you've remembered that, then it's time to obviously to see if those values match what we're saying, that it's always going to be a constant. So you need to multiply them together. So you're going to multiply all of these values by each other and see if they're all the same. So just multiplying these will get you a mark. In fact, if you do more than one, you get 2 marks, which is very generous. So you multiply them all together, and looking at those values, they are all very similar. So you've got 2 that are the same, and the rest are all very similar. So with this one, I would say yes, the values do agree with the relationship between pressure and volume. They do agree with Boyle's law.